Hello. Okay, hi everyone. Hope you all are good. We are here for grade 8 math. So we're working on the book Math Makes Sense grade 8. I think Pearson it is. Math Makes Sense. We're working on the chapter data analysis and probability, that is chapter 8. The lessons we're going to cover today are probability of independent events and solving problems involving independent events. So let's just start with the first lesson. Okay, we are already working on the chapter probability on the lesson probability of independent events, and I think we have done till question number 9. So let's just start with question number 10, right? Okay, question number 10 is here it is. A dresser door contain 5 pair of pairs of socks of these colors brown, blue, brown, green, white, and black. The socks in each pairs are folded together. Pin to reach into the drawer and take a pair of socks without looking. He wants a black pair. What is the probability that Pintu takes the black pair of socks on his first try? And the second one is what is the probability that Pintu takes the green pair of socks on his first and second tries? What assumptions can you make? Okay, so he have total 5 pairs of socks, right? You can see here blue, brown, green, white, and 5. So total pairs are 5, right? So the probability for black is for the first time, the probability of black is 1 out of 5 because out of 5, we just one pair that is black, right? So for the B part is what is the probability that Pintu takes the green pair of socks on his first and second try. So in the question, you are not given that the the black socks he uh, takes in part A, he put back, right? So let's just assume they are the independent events, right? So the probability of what is the probability that Pintu takes the green pair of socks on him? Okay, both the tries he have the green pair, right? So the probability of green is also 1/5. Probability of green is 1/5. So you have to first and second try both are green. That means probability of green and green. It would be 1/5 times. Let's just do it on board. Okay, the probability for black is 1/5, right? Because you have 5 colors and out of 5, just one of them is black. Now for the B part, you have to calculate the probability of green. Okay, out of 5, you have just one pair that is 5. But in the question, what is the probability that Pintu takes green pair of socks on his first and second try? So in both try, he get green. So the probability of green and green, it would be 1/5 times 1/5, that would be 1/25, right? Okay, the C part is what assumption do you, the assumption I made for B part is like you're not given that the black pair of socks he takes in A part he put back, right? So we the assumption we took for B part is the events are independent, right? Okay, let's just number 12. A bag contains 6 red marbles, 4 blue marbles, and 2 yellow marbles. A student removes one marble without looking, records the color, then return the marble to the back. The process is repeated. What is the probability of each outcome? A red marble, then a yellow marble. Okay, so he have 6 red, 4 blue, and 2 yellow. He have 6 red marbles, then he have 4 blue marbles, and 2 yellow marbles, right? Okay, the first part is what is the probability of each outcome? A red marble, then a yellow marble. Okay, the probability of red and yellow, right? Let's just calculate the probability of red and probability of yellow. So the probability of red is the total marbles are 6 and 4, 10 and 2, 12. 12 total marbles, right? So the probability of red is 6 of the marbles are red, right? It would be 6 out of 12 or either 1 over 2. And the probability of yellow is 2 of the marbles are yellow. It would be 2 out of 12 or 1 out of 6. So to calculate the probability of red and yellow, you have to multiply both the probabilities 1 by 2 times 1 by 6. It would be 1 over 12. That is the probability of red and yellow, right? Okay, for the B part, 2 blue marbles. Okay, he selected 2 marbles and they both are blue. So probability of 2 blue, that means probability of blue and probability of blue. Okay, so for the you have 4 blue marbles, so the probability of blue is 4 over 12, that would be 1 over 3, right? So it would be then 1 by 3 times 1 by 3, that means 1 over 9. Okay, the C part is not a blue marble, then a yellow marble. Not a blue means either it is not a blue and yellow, right? Not a blue means the other colors are, then not blue means it would be probability of red, and yellow. 6 and 2, 8, right? Probability of not blue means, let's just calculate the probability of B blue first, right? Probability of blue is 1 over 3. So probability of not blue is 1 minus 1 over 3. That would be 3 minus 1, 2 over 3. So the probability of not a blue is 2 by 3. And the probability of yellow is 1 over 6. So it would be 2 times 3, 6, 1 over 9. The correct option is 1 over 9. Right? Okay. The B part is suppose that marbles are not returned to the bag. Could you use the rule of two independent events to find each probability in A part? Why or why not? Okay, so suppose the marbles, okay, if you are not returning the marbles back, right? So that means the probability, the events are dependent and they are not independent, right? So could you use the rule of two independent events? No, you cannot use the rules of independent event, because if you are not putting the marbles back, that would be the dependent events, right? You have to then use the rules for the dependent events, right? Okay, let's just start with question number 13. Luke and Serena play the card game Slam. Each player has 10 cards numbered 1 to 10. Both players turn over one card at the same time. The player the player whose card has the greater value gets 1 point. If both cards are same, a tie is declared and no point is given. After each round, the card is returned to the pile and all the cards are shuffled. Find the probability of each event. Luke will get 1 point when he turns over a 3. Okay, hold on. 10 cards, numbered 1 to 10. Okay. So for the A part, what you have to do, you have to, Luke will get 1 point when he turn over a 3. Okay, over a 3 means you have only two numbers that are less than 3. They are 1 and 2, right? So you have to calculate for the A part, you have to calculate the probability of x less than 3, because over 3 he have 1 point. You have to calculate probability of x less than 3. You have two numbers that are less than 3, 1 and 2, right? It would be 2 over 10 because the total cards are 10, so it would be 1 over 5, right? Okay. Selena will get 1 point when she turns over a 10, right? Okay, so if Selena get a point when she turns over a 10, that means Luke must turn over any number less than 10, which is 9 outcomes, right? So in the B part, that means you have 9 outcomes. So probability of x less than 10. For B, you have to calculate probability of x less than 10. That would be 8. You have 9 numbers that are less than 10, so it would be 9 over 10, right? Okay, the next one is Luke and Selena will tie. Okay, tie is in the case if both cards are same, right? That means both the cards are same, so they have a tie. For the C part, they have a tie. You have to calculate they have same cards, right? For example, probability of x and probability of x. That would be then probability of 2x, right? So probability of x is 1 over 10, right? So it would be 1 over 10 times 1 over 10, that equals 1 over 100. So you have 10 cards, right? So the probability of 2x is 10 times 1 over 100. That would be 1 over 10. Okay, the next part is Selena will get 1 point when she turns over a 1, right? That means over a 1 means the opponent have the number less than 1. Less than 1, you don't have any number. It would be 0 over 10, and that equals 0, right? Okay, let's just look at question number 15. A coin is tossed. A coin is tossed and a die labeled 1 to 6 is ruled. Write an event that has each probability. Write an event that has each probability below. Okay, 1 by 2 is the event for the coin, right? Because coin has only two options that are head or tail. So the probability of head and tail, they both are 1 by 6. And 1 by 6 is the probability of the uh, die, right? Because on a die you have numbers 1 to 6. So 1 by 6 is the probability of the. Okay, C is 1 over 3. So 1 over 3 is the probability if you toss a coin. Okay, you have to write down the events that have the probability 1 over 2, right? So if you get the probability of head, probability of tail, and probability of even numbers, they all are 1 over 2. Okay, so we are done with the lesson. If you have any question, you can please ask. Okay, so we are done with the lesson. Let's just start with the next lesson. The next lesson is 7.4, that is solving problems involving independent events. So still we're working on the independent events. We have to solve the problems that involve the independent events. So let's just start with the lesson. Okay, here is the practice questions. Let's just start with the practice questions. Okay, let's start with question number 4. One coin is tossed 3 times. Find the probability of each event. The first one is 3 heads, 3 tails. Okay, let's just start with the 3 heads and 3 tails. So probability of one head is 1 over 2, right? So the probability for head every time is, question number 4 it is, we have to calculate the probability of 3 heads. Question number 3, probability of 3 heads. That means every time you have you have to do probability of head time probability of head times probability of head. And we, for the head, we know that the probability is 1 over 2 because the events are independent, right? You have the same coin, so the outcome have the same ways, 1 over 2, 1 over 2 times 1 over 2. So it would be 1 over 8, right? So for the B part, you have to do probability of 3 tails, that would be exactly same, because for each tail you have the um, okay. Then for the C part is probability of head, probability of tail, then probability of head, and then probability of tail for the C part. Tail, head, tail. Probability of tail, head, tail, right? So the probability for tail is every time 1 over 2, right? So it would be 1 over 2 times 1 over 2 times 1 over 2. So when you do calculations, it would be 2 times 2 is 4 and 4 times 2 is 8. So it would be again 1 over 8, right? Okay. Okay, let's just start with question number 6, because the lesson has so many questions. I am going to skip some. So you have to try the ones I skipped on your own, right? So let's just start with question number. A red die and a blue die and a green die ruled. Each die is labeled 1 to 6. Find the probability of two events, a 2 on the red die and a 3 on the blue die and a 4 on the green die. Okay, let's just start with question number 5a. That is probability of 2R. I'm going to write red with 2R, 3 on blue die and 4 on green die, right? So probability of 2, 4 and 2, 3 and 4 it would be. Probability of 2, 3 and 4, right? So that would be a die. The probability of 2 is 1 over 6. Probability of 3 is also 1 over 6. And probability of 4 is also 1 over 6, right? So that means you have to multiply the probability of 2 times the probability of 3 times the probability of 4. It would be 1 over 6 times 1 over 6 times 1 over 6. So 1 times 1 is 1, 6 times 6 is 36, and 36 times 6 is 1 divided by 260, right? Okay, then the next one is or a 4 on red die and even on blue die and a number less than 3 on the green die. So it would be 4 even and less than 3. For the B part, it would be probability of 4 even and right. So the probability of 4 is 1 by 6 and the probability of even is 3 out of 6, right? Because out of the 6, 3 numbers are even. Probability of 4 is 1 out of 6. Probability of even is out of the 6 numbers, 3 of them are even. So it will be 3 over 6 or either 1 over 2, right? And then the probability of 3 greater than 6, right? No, x is greater than 3. So it would be 1 over 3. So you have to multiply all the probabilities. For probability of 4 is 1 over 6, probability of even is 1 over 2, and probability of x is greater than 3 is 1 over 6, 3. 3 times 2 is 6 and 6 times 6 is 36. So it would be 1 over 36, right? Okay, we are done with the question. Let's just move on to next one. We're done with 5. Let's start with question number 7. Stanley's bicycle lock. Stanley's bicycle lock has 4 dials, each with digits from 0 to 9. What is the probability that someone could guess the combination on the first try by randomly selecting a number from 0 to 9 four times, right? Okay, so you have to calculate the probability. What is the probability that someone could guess his combination on the first try by randomly selecting a number from 0 to 9 four times? Okay, so that means that would be, okay, that is a log and four numbered log, right? For example, the numbers are W, X, Y, and Z, right? So you have to calculate the probability of W, probability of X, probability of Y, and probability of Z, right? W is the number on the first dial, right? You have 0 to 9 numbers, it would be probability of W is 1 over 10. Then probability of X is again same 1 over 10. And probability of 4 is 1 over 10. And the probability of Z is 1 over 10. When you multiply them, it would be 1 over 10000, right? Okay. Okay, let's just start with question number 9. Nadine, Joshua, and Shelley each have a standard deck of playing cards. Each student random draw a card from the deck. Find the probability of each event. Each student draws a height. Okay, each student draws a heart. So each student randomly select draw a card from the deck, right? That means they have their own cards, right? So the output doesn't depend on each other, they are independent events, right? Okay, each student draws a height. That means they all have heart, they all have heart, right? It would be probability of three hearts, probability of heart times probability of heart times probability of heart, right? So you have total 52 cards. 13 of them were heart, right? So it would be 13 over 52 is 1 over 4 times 1 over 4 times 1 over 4. So it would be 4 times 4 is 16 and 16 over times 4 is 64. Okay, then the B part is rolling for the first two songs played by. Oh no, we are working on question number 9B. Nadine draws a spade, Joshua draws a spade, and Shilly draws a red card, right? So you have to calculate the probability of spade, spade, and red. Okay, let's just calculate the probability of spades. Okay, again you have 52 cards out of 13 were spade, so it would be 13 over 52 or either 1 over 4. And the probability for the red is you have 26 cards are red, half of them are red and half of them are blue, right? So half of 56 is 50, half of 52 is 26, right? So the probability of red is 1 over 2. You have to calculate the probability of spade, and red spade is 1 over 4 times 1 over 4 times 1 over 2. So it would be 4 times 4 is 16, and 1 over 32 is the probability of spade, and red, right? The C part is Nadine does not draw a heart, Joshua draws a black card, and Shirley draws an ace. Show your work, right? So not heart. You have to calculate the probability of not heart, then probability of black, and then ace. Okay, you have to evaluate probability of not heart, black, and ace, right? Let's just calculate the probability of not heart. Okay, so you have to calculate probability of heart. You have to subtract 1 from the probability of heart. Probability of heart is 1 over 4, right? So that means probability of not heart is 1 minus 1 over 4. That would be 3 over 4. That is the probability of not heart. You have to calculate the probability of not black. So not black means you have 26, card 52. That would be 1 over 2. So probability of black is also 1 over 2, right? Okay. The next one is, okay, show your work. Probability of not heart, not black, and ace is not heart is 3 over 4, not black is 1 over 2, and then probability of ace is 1 out of 3, 1 out of 13, right? When you multiply them, it would be 3 divided by 104, right? Okay. Okay, let's just start with question number 11. Rocco chooses a 3-letter password for his email account. He can use a letter more than once. What is the probability of someone else can access his email by randomly choosing 3 letters? Okay, 3-letter password. He can use a letter more than once. That means repetitions are allowed. So, what is the probability that someone else can access his email by randomly choosing 3 letters? Okay, so that means you have to select probability of the 3 letters, right? X, Y, and Z. It would be probability of X, Y, and Z. That means you have to calculate probability of X, probability of Y, and probability of Z. X, Y, Z, and the letters, right? So probability of X, because repetitions are allowed, right? Means you can select any out of the 26. So for Y and Z, that is exactly same because the repetitions are allowed, right? So then that means the probability is 1 over 26 times 1 over 26 times 1 over 26. Let's just multiply them. It would be 1 over 1700, 1776, right? Okay. The next one is question number 13. A pack contains 5 blue marbles and 1 white marble. Susan draws a marble from the bag without looking, then places it in the bag. This is done 5 times. What is the probability that the white marble is drawn 5 times in a row? Express your answer as a percent. Okay. Okay. 5 blue and 1 white marble, right? So, what is the probability that the white marble is drawn 5 times? So, you have to calculate probability of white, right? White marble is just 1, and 5 of the marbles are blue, so the total marbles are 6. The probability of white is 1 over 6, right? Because the total marbles are 6, it would be 1 over 6. It is 1 over 6, right? So you have to select the white marble 5 times. So you have to multiply this probability 5 times, right? You have to do 1 by 6 times 1 by 6 times 1 by 6 times 1 by 6 times 1 by 6. You can multiply and get your answer, right? The B part is, suppose that white marble is drawn 5 times in a row. What is the probability that the white marble will picked up on the next draw? So 5 times in a row and then again white marble. That means now you have the probability of white 6 times, right? So you have to evaluate for the B part, you have to evaluate 1 over 6. You can write 6 times, right? Just evaluate using calculator. That would be your answer, right? Okay. Let's just do question number 15. In a gym class, students take turn shooting a basketball at the net. Each successful shot is worth 1 point. A player is awarded a second shot only if the first shot is successful. The player can score 0, 1, and 2 in this situation. Suppose a player shoots with 70% accuracy. What is the probability of each event? She scores 0 points, she scores 1 point, and she scores 2 points. Okay. 70% accuracy, right? Probability of scoring is 70%. Okay, question number 15. You are given the probability accuracy is 70%. So probability of scoring is 70 over 100, right? Because it is 70%. So that means the probability of not scoring is 1 minus 70 over 100. It would be 1 minus 7 over 10 and 10 minus 7, 3 over 10 it is, right? Okay, now you have to calculate probability of 1 point. That means that is the probability of scoring and probability of not scoring. So we know that the probability of scoring is 70 over 10, or you can say 7 over 10, and probability of not scoring is 3 over 10. That would be 21 over 100. Then you have to calculate the probability of 2 points, right? That means it would be probability of scoring and scoring, right? So that means you have to do 7 over 10 times 7 over 10 because the probability of scoring is 7 by 10. So 7 by 10 times 7 by 10, that would be 49 over 100, right? Okay, we are done with the lesson. You can do the question number 16 by yourself, and also the questions I skipped. You have to do them on your own, right? They are very easy. You just have to try them on your own. So you can ask question if you have any. We were working on grade 7 math. We are working on the chapter data analysis and probability. And the lessons we have covered today are probability of independent events and problem solving problems involving independent events, right? So please ask question if you have any. No questions? No questions? Okay, then that's all for today. See you in the next session. Bye everyone.